In this video, we're going to talk about left turning tendencies of the aircraft. The four left turning tendencies, as we see here, are torque, gyroscopic precession, P-factor, and the spiraling slipstream. Alright, this first little picture here shows torque. Well, what torque is for every action there is an equal but opposite reaction. And with the propeller spinning in a clockwise, when viewed from the cockpit, in a clockwise rotational manner, the airframe wants to turn the opposite direction. That's the effect of torque on the aircraft. That provides one of the left turning tendencies. The other is gyroscopic precession. Now, if you had a disc spinning and you put a force up at the top of it, just like this propeller is spinning, and we put a force at the top, that force is felt 90 degrees in the direction of the rotation. So we push at the top, and it's felt 90 degrees in the direction. So if you took like a bicycle tire and you spun it, and then you went to turn it, you'd feel kind of a weird motion on your hands. And that is the gyroscopic precession. Gyroscopic precession is also in our gyro instruments in the aircraft, and that's why they precess due to all the different forces, and so we have to always be checking those, such as the heading indicator. Now, this is probably most predominant in a tailwheel aircraft. So when you are rolling down the runway with all three wheels on the ground, you're still getting some left turning tendencies, but then the gyroscopic precession kicks in when you raise that tail up and you're forcing that prop forward. You're going to get a lot of left turning tendencies there. So if you're getting your tailwheel rating or endorsement, one of the big things that you have to figure out is how much rudder to use when you bring that tail up. Okay, spiraling slipstream. When the propeller is spinning and creating thrust, some of that air moves over the aircraft, and it slips around and it hits the tail, causing a yaw in the left direction. Nose left direction. So it hits the left side of the vertical stabilizer and rudder and pushes the nose left. Pushes the tail to the right, brings the nose to left, a left turning tendency. And then the asymmetric prop, or P-factor. Okay, what P-factor is, I don't know how well you can see this picture. Let me zoom in a little bit. Zoom in. Okay. The training aircraft are typically at a positive angle of attack when flying, straight and level even. But it's much more pronounced when you're taking off. And you have that descending blade taking a larger chunk of air than the rising or ascending blade, or the left side of the prop. So you get a little bit more thrust coming off of the right side of the propeller than you do the left side of the propeller. And that P-factor causes a left turning tendency. How do we stop left turning tendencies? Right rudder. So you might hear your flight instructor say right rudder, right rudder, right rudder when you're trucking down the runway. It's because you're veering off the center line going towards the grass, and he wants to stay on the center line. Center line is your friend. Do whatever you got to do to stay on it. Right rudder. Now, this is also felt once you lift off. It's not just on the runway, but it's also felt when you just lifted off, and let's say you lift off the runway, you're climbing out, and you take your feet completely off the rudder pedals. Well, which way is the ball going to swing? It's going to be swung to the right. And what do? We always step on the ball. And you might hear your instructor say, step on the ball. Meaning, whichever way that inclinometer is outside of the little hash marks. If it's outside on the right, you use your right rudder. If it's outside to the left, you use your left rudder. You step on the ball. So you step whichever way the ball is out, you step on that particular rudder. And you'll overcome your left turning tendencies, and you'll have a nice smooth flight.